If you're looking for an open source solution securing your Kubernetes cluster from networking, vulnerability, runtimes, and more, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the security playlist where we cover a couple of episodes. We recently explained the security best practices related to Kubernetes, and we introduced OPA Gatekeeper and several runtime security agents of the market like Falco or Tetragon. Today's episode is going to be focused on another CNCF project that offers several security features for our Kubernetes clusters, and I'm referring to Kubescape. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what we're going to learn from this episode. We'll start presenting the Kubescape project. We will then focus on the specific features covered by the Kubescape Operator. We'll focus on the vulnerability features, the security scans, the networking features, the runtimes threat detections, and of course we will cover, as usual, the observability part related to the Kubescape Operator. Kubescape is a CNCF project initiated by Armo. I had the chance, if you remember, to discover Kubescape at KubeCon Amsterdam. By the way, here is the episode related to Amsterdam. At that time, Kubescape was mainly focused on providing a CLI that could be used to scan our YAML files or scan for vulnerabilities at the runtimes of our containers. But things have changed a lot. Kubescape project is not only a CLI, but also provides an operator providing many features in a security space, and it's insane. When using the CLI, you would be able to scan our cluster against regulation frameworks such as NSA, CSI, or MITRE. A security framework, for those who never heard about it, is a set of guidelines, best practices, or standards usually codified as a number of controls. The security frameworks are often published by government agencies or non-profit research centers. Kubescape provides several controls that can be used, or we can even create our own controls. The controls are tests that will look at certain aspects of our security posture. Kubescape can look at Kubernetes objects, configuration like YAML files or Helm charts or any resource that the API server will expose. It will also look at the API server settings, the worker nodes, so the configuration of the worker nodes that we have in our clusters, including kubelets, container image, so it could be the results of an image scanning to give you high-level visibilities on the items that you need to pay attention within your clusters. Behind the scenes, Kubescape relies on Rego language and use OPA to evaluate the rules. To add your custom rules, control of frameworks into Kubescape, there is a step-by-step guide at the following URL. To use the Kubescape CLI, it's straightforward. You only need to use the command scan. So kubescan scanned and a given framework like NSA, for example. Like mentioned, the CLI can also scan your YAML files or Git repo. So kubescan scan your YAML files, or you can also specify a specific control that you want to apply on that YAML files. The CLI even allows us to define an acceptance risks that you could configure to exclude specific workload or namespace for a given control or a given framework. For example, in this example, we are excluding the deployments of the default namespace and on the control C0060. The acceptance risks is a JSON file that describes the name of the exceptions, the type of actions, the resource targeted by the acceptance rule, and last, the posture policy concerned by this rule. But using the command line is nice, but having an actual solution that continuously scans our cluster is even better. And that is where the operator brings so much value. The operator provides more features compared to the standard usage of the CLI. It can, of course, scan for misconfiguration, scan for deployed images for vulnerability like CVEs. It will also detect runtime vulnerabilities, and it's covered even more features. The operator has the ability to connect to a provider. For now, there's only one provider, which is Armo. The usage of the provider is interesting not only on the data exchange, but also because the provider could trigger actions like configuring network policies, triggering scans, and even more. But if you don't use any provider, it is not a big deal because by default, the operator peruses lots of data. And more exciting part, it utilizes the open telemetry format. Of course, each individual component produces logs, but each of those logs are also emitted using OTLP logs. Before going into the details, let's look at what you will get once you deploy the operator with Helm. You will get several components. You will of course get first the operator, a deployment that will be in charge of managing the CRDs that this operator brings in your cluster. You'll see that it brings a lot of CRDs. Then you have Kubescape is another deployment that will run the similar type of results that produced by the CLI. So all the framework regulation stuff that we covered a few minutes ago. Then we have Kubevul. It's another deployment that will be in charge of scanning our workload and report vulnerabilities at the runtimes of our containers. Then we have Nodeagent. It's a daemon set that will be in charge of detecting runtime threat detections. It will also scan the traffic of our applications to produce network policies. This daemon set relies on eBPF and is crucial because it helps securing our network communications and detecting suspicious events. Last, we have a storage. It's a deployment designed to store the various data of the operator. It exposes the data in the Kubernetes API. Then we have an optional component, the hotel collector, that it will be another deployment with, of course, an OpenTelemetry collector with a pipeline, and this will only be there if you're using the provider Armo. Each components are configured to produce logs, metrics to this collector, but also to your own collector. Meaning that currently, to export the data out of Kubescape, you can define an OTLP endpoint, and that will be sent to this collector. In my case, I'm sending the data to my own OpenTelemetry collector, so not the default one provided by Kubescape, so I can basically play with the data and enrich data and filter and whatever I want. Because it's an operator, there will be a lot of CRDs added in the cluster. And there are various CRDs depending on the various features covered by Kubescape Operator. So there will be the vulnerability, the networking, the threat detections, and even more. So let's cover them one by one. Starting with the vulnerabilities, meaning that it will store different results of the scan executed by Kubevul. You'll see that it has different CRDs providing different level of details. So let's start with the higher one. So the vulnerability summary that summarizes the vulnerability that has been detected on a given namespace. You will have one object per namespace, and this object will list all the details, so the vulnerability manifest summary produced in a given namespace. And it provides a summary view on the number of critical, low, medium severity detected in this given namespace. Next is the vulnerability manifest summary that store the details of a scan of a given workload. So Kubevul will produce this CRD with the overall results of the scan showing you the critical, the medium, the low severity details of a given workload. To highlight the details of these results of this, you have another CRD called vulnerability manifest that will link all the details of all the vulnerability detected on this given workload. So you can get the results by simply doing a describe on these objects. So simply by running kubectl describe vulnerability manifest summary or vulnerability manifests and the name, of course, of the object name. So like I said, vulnerability manifest will hold all the details produced by Kubevul. It is usually stored in the Kubescape namespace and will show each vulnerability detected, the CVE numbers, the descriptions, and more. To produce relevant vulnerability scans, Kubevul will rely on another workload, the Nodeagent, that will produce an SBOM files on the library actually loaded by the application. It is almost like a runtime scanner. So the Nodeagents will produce this other CRD named the SBOM stored in the Kubescape namespace. These results will be used later on by Kubevul to focus on the vulnerability detections on the library actually loaded by the app. Similar to the other CRD, to get the details, you will only need to do a describe on the object. What is interesting is that the vulnerability scans are done by using another CNCF project called Gripe. The scan is triggered every time we deploy a new workload, and it's also triggered every day at midnight. Kubescape Operator, like mentioned, can help us defining the network policies. Nodeagent is scanning for the traffic of our applications and produces a CRD called Generated Network Policies. This CRD contains the actual network policy that we could create on a given namespace. So the operator produced this CRD, but it won't generate the network policy. So it's going to be up to you. The CRD at the end contains the actual specifications with the network policy. So for example, here is generated network policy. And as you can see in the specs, you will find the actual network policy objects that we could apply in our cluster. To get a precise network policy, it is recommended to let Nodeagents sniff the traffic for a certain period of time to get a precise rule. We call it the learning time. Behind the scenes, Nodeagents is producing an object called network neighborhood that will contain the incoming and outgoing traffic of our workload. We can fine-tune the productions of the network policy by creating what we call a known server, where we could help Kubescape to define your egress communications, or to GitHub, for example, or to your Observability backends. Kubescape Operator can regular scan our cluster workload against the various control, rule, framework supported by the Kubescape CLI. This will trigger jobs that will trigger scans in our cluster. Of course, this feature will be managed by the Kubescape workload, and similar to the other feature of the operator, the results of the scan will be stored in a CRD, workload configuration scan summaries. It will produce a summary for the entire cluster, the namespace, and the workload. To get the details, you will simply need to describe the objects produced. This feature is amazing because it includes detections of suspicious events in our clusters. Of course, as any runtime security agent, it relies on eBPF to detect events. In this particular case, Kubescape is using inspector gadgets to trigger various gadgets detecting file, processes, networking events, and more. But where Kubescape brings a new way of handling runtime threat detections is through the approach of learning. The Nodeagent will learn what our workload is using in terms of processes, capabilities, syscalls, and more. And all these details are stored in a CRD called application profiles. The idea is to detect changes from the learning phase, and if suddenly a new capabilities or a new process has been used in our workload, then it may sound suspicious. The other beautiful about the runtime threat detections is the ease of use. It provides a CRD named Runtime Rule Alert Binding that defines the type of controls we would like to apply in our workload. By default, the operator creates one CRD on each namespace controlling all the pods on all the available controls. Kubescape is controlling many things, of course, well-known attack patterns. So here is the list of the rule defined in the runtime threat detections feature. But it covers an expected processes launch, an expected capabilities, an expected Kubernetes clients, an expected process spawned, any crypto mining or malicious SSH connections. What is amazing is that we don't have to go through a complicated journey of defining our syscalls or events or processes that we would like to capture. We simply need to turn on or off one of the controls supported by Kubescape. So in terms of user experience, it is awesome. If a rule is being violated, the Nodeagents will produce an event in various formats, but the best would be to collect them using logs because it's going to be thrown in stdout. Kubescape by design has a core integration with OpenTelemetry. When I saw this, I was initially very excited, but there is a small limitation. Now Kubescape can come with its own collector, but you can customize it by using your own collector, meaning that your collector will receive OpenTelemetry data, so logs, traces, and metrics, that you could then enrich using the Kubernetes attribute processor to attach those signals to the Kubescape workload. When that is done, the Kubescape data will be attached to the right components, so Nodeagents, Kubeview, Kubescapes, and more. So what do you actually get? Well, you get traces. It is very interesting, but it's a bit hard to use, especially if you're not a Kubescape maintainer. Then it produces OpenTelemetry logs. So I first removed the Kubescape namespace from a collector with the file log receiver, and I quickly discovered that only technical logs are emitted through OpenTelemetry. So the relevant log from the user perspective, such as the runtime threat detections and other, are only pushed in stdout, meaning that the OTL logs are nice to simplify our parsing journey, but in our use case, it is a bit limited. So I would recommend for now to read the logs from the Kubescape pods. Parsing the logs are very easy because they are built in a JSON format. Because they produce lots of details, you may have data cropped by default settings of your Observability backends. To avoid this, I recommend to use the collector, the transform processor, to parse the JSON log into log attributes. This will split the data in various log attributes and avoid any extra settings that you may have in your Observability backend. Using the file log would be crucial if you're interested to report the details related to runtime threat detection. In OTL logs, you won't find any results of any scans triggered by Kubescapes. I remember this data is only available in the CRD level, same as the network generated policies. So the best would be to use the Kubernetes object receiver that will pull the contents of those CRD into a log file. Of course, to achieve this, you will need to create the right airbag for your OpenTelemetry collector. Then I will manage this data to produce events, metrics. This really depends on your Observability backend. In my case, I'm using Dynatrace that has the open pipeline that allow me to do this. With this approach, you will get the scan results, the network policies, and even more. This data will be super relevant to report security dimensions of any workload running in your Kubernetes environment. Next is metrics. So I started my journey by only looking at the OTL metrics produced, but where it's a bit confusing. You will see that you may get more details related to the Go runtime behavior, which is at the end very good, because I love to see if there is any massive garbage collector running in Kubescape, could explain any potential performance problem. By other than the Go runtime, you can only get metrics about the operator, like the number of objects managed by the operator, and so on. But what about the rest? The runtime threat detections and so on? Well, the details about the runtime threat detections, the scans, would be available when enabling the Prometheus exporter on the Nodeagents. To get that extra details, you will need to scrape the data from the Nodeagent. So out of this data, I recommend to report a couple of things. As any solutions, you will start by reporting the health of Kubescape components, and for this, we will need to report infrastructure details, like meaning the resource usage, CPU, memory, and so on. So you can either do this with the OpenTree collector, host metrics receiver, Kubernetes stat receiver, Kubernetes cluster receiver. In my case, I'm using the Dynatrace operator that report the health of all the pods of my cluster. That is more enough for my case. Then Kubescape emits OTL metrics on each component related to the Go runtime. So I will collect those metrics to report the heap size, the garbage collector durations, the Go routines, and so on. Other metrics, it also produces spans, so I will report the P99 durations of the root spans on each component to see if anything is slow, and have dedicated sections to report a span that may be an error to see if any components of Kubescape are running unhealthy or there's a potential problems. Last, we have the logs that could report any technical errors during scans or runtime threat detections. So it will be in the logs that we get the details. To collect and parse it, it will be useful to see any potential issues of any Kubescape components running to scans or detect problems. On the actual results of the scan, I rely on the metric exposed by the Nodeagents, sharing threat alerts, eBPF events, and more. This will be interesting to report any security issues that could happen in your cluster. I was able to produce the following dashboard reporting the health of Kubescape components and also focusing on the security aspects, reporting the scans, the runtime detections, and more. At the end, it relies mainly on logs and metrics and a bit on the span produced by Kubescape as well. Overall, Kubescape produces data, but the data collections required to understand the solution to see what and where we should collect the data. Having an auto integration, I think, is great, but a bit confusing for the user because we're thinking that we will get everything from this source. But again, I'm convinced that this will be improved in the future, and we could mainly rely on open telemetry to get all the data from Kubescape. As of now, as you can see, it's a bit of logs, it's a bit of Prometheus, it's a bit of CRDs, it's a bit of metrics, so a bit everywhere. But I'm pretty sure that this will change with the future release of Kubescape. That's it for today's episode related to Kubescape. As you can see, Kubescape, I think it's very exciting because it covers in one solution all the security features that we need in our cluster. So this runtime scan of our containers, security posture management on anything running on the cluster, the network policies, suggestion network policies that we can apply in the cluster, and the runtime threat detections. In the runtime threat detections, I really like the approach that they have taken, where there's a learning phase, knowing what is normal, and then the scan, the runtime of the Nodeagents will basically compare to what is normal compared to what we have. If there's a difference, then it could be suspicious. The configuration of the runtime threat detections is just a toggle. So I thought, well, that is great. So you don't have to configure the events, configure the syscalls or whatever that you may have in other solutions. So if you are a bit not an expert in the security space or kernel space, I think this is really exciting, really easy to get onboarded and get details. All the details, I think it's great, are stored in those CRDs. You can see that there are a lot of CRDs that is provided by Kubescape. So having the details and be able to parse it and get it in any solution, I think that is just exciting. On the other side, compared to other solutions of the market, it produced tons of things. I mean, the logs has a lot of details, the metrics has a lot of details, and it also produced spans. And like I said before, it has a lot. The open telemetry integration is amazing, but as of now, it's confusing. You need to understand that you will probably need the logs, then the metrics, and the traces and the logs from the open telemetry side. But mainly, I think that from the user perspective, we will probably rely on Prometheus, the logs, and maybe the CRDs. The rest is nice and more about reporting the actual health of the operator. And this is, again, very useful. If you have to operate Kubescape in your cluster, you may want to know if it's running smoothly and is healthy. And I think it makes sense to get that data. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.